we've got the units, and so I'm gonna let you go to lab, but I want to lecture first here. But we've got 10 units out there labeled. Now there's one over there that's not labeled, kind of in between the two sets. It doesn't have a number on there, so don't do it. And I'll give y'all today, Monday, and Wednesday. It may not take you 3 days, but this is the first time we've done it, so we'll see. Yeah, I would suspect the night class where there's more people getting in each other's way. But anyway, so we'll have Monday. We'll have today, Monday, and Wednesday to do it. But normally we'll just have a Monday and Wednesday when I reset them.
This lab A you're talking about?
That's what we were talking about the other day.
So this is what you're talking about, right? I'm not, this is what you're referring to right now?
No, these are brand new labs.
I'm sorry.
That's all right. And so what you'll have to do is you'll have to write today's date if today's when you're doing it, or it's Monday, or it's next Wednesday. But here's the date and the unit you're working on, like unit 3, because each unit may have a different problem. And then when I reset them, if they don't have the right date, I'm gonna mark it wrong, because you said, well, Now, we need to lay down some rules. Okay. Do not fix my equipment. You have a meter for a reason, to use it, to know what it's trying to tell you. You don't want to be one of these people who constantly change parts. They go back to the supply house. They hate to see you coming. What's he bringing back? And for the most part, most time in policies, once you open that case, if it's an electrical part, it's yours. And we don't want to do that anyway. Occasionally you may get bit on something maybe you didn't understand, you misread it. But you want to figure out what it is that's wrong, and these are all electrical problems right now. And you're going to write down what you think the problem is and why. If you say bad transformer, well, why do you think it's a bad transformer? Because I owned out the coil, primary coil, OL, or maybe it's the secondary, that kind of thing. Say I've got a contactor that you think is bad. Why? Coil's bad, or maybe the contact's bad. I don't know. Unit doesn't have proper voltage. What did it have? What were your readings? Okay? So that's how we're going to handle these labs. Another thing is, when possible, when you leave the unit, put the cover back on. It doesn't take too much longer. If there's somebody waiting right behind you to get on that unit, okay, they'll put it on. But somebody, before you leave in the afternoon, you put the covers back on. You wouldn't leave them off at a customer's house, okay? So everybody understand the rules? Okay, so I'm going to start here on page 305 of that handout I gave y'all on voltage high. Voltage high. We talked about that if it's single phase, we have a tolerance of plus or minus 10%, right? It says at no time should the voltage supplied to a condensing unit be higher than 10% of the normal voltage rating of the unit. Therefore, a 240 volt unit, the maximum applied voltage should not exceed 264 volts. Higher voltage than normal subjects the unit to higher current draw with attendance damage. That means the more you use it like that, it's building up. To the motor windings, control contacts, relay coils, and shortens the life of the running capacitors. High voltage problems are usually more difficult to detect. Remember that refrigeration unit or air conditioning unit has to operate 24 hours per day, 7 days per week. High voltage usually results during nighttime hours and or weekends when the commercial and or industrial loads on the same power distribution systems are at a minimum. As high voltage problems can be handled only by electric utilities, They should be contacted when this problem occurs. Alright, so when you get to the customer's house, if it's above the 10% range, I would recommend probably going to their breaker box and checking the power coming in, because it's probably, if it's high on your, air conditioning circuit, it's probably high on everything. Okay, this is the problem. Like we said, if we've got higher voltage, means I got higher amperage. We look at the formula. Higher amperage means more heat. Everything's breaking down earlier. Nothing we can do about it, but you need to tell the customer they need to contact their, either Alabama Power or whoever they're buying their power from. Maybe just a transformer in their neighborhood or a section of their neighborhood, something that simple. Now, personally, I would be somewhat guarded as what I told my customer, because you start telling them stuff, they're going to go, yeah, my TV went out, we had a stereo, I would not start telling them all kinds of things like they're going to get money from Alabama Power. But, Alabama Power will come and correct the problem, because they know that consumers do have lawyers, and everybody in the neighborhood is going to start calling. So, but there's nothing we can do to fix it. But if you detect it, all you have to do is use your voltmeter, right? Okay. And this is, that may not what you came for. You came because there was a problem. You check and say, hey, my part's out, the transformer, something like that. You put it back in, you get the system running, and you go, wonder what caused this. And that's why you would check it, a voltage check, and you go, oh, this thing's way out of range. All right, let's look at voltage load, section 2313. This sounds like a test question. Low voltage is the most common voltage problem. So chances are it's going to be low, not high. Single phase units are designed to start running a minimum voltage of 10% below rating. On a 240 volt unit, that means 216. Anything below it, we don't even know if it's going to start. On a 3-phase unit, the minimum is 5%. That means that the minimum applied voltage for a 3-phase 208, 230 volt unit would be 197. Now here they're going to explain that. If the applied voltage is under these minimums, the unit either fails to start or delays long enough to blow start capacitors, start relays, burn up contacts and overloads, and burn compressor motors. Because considerable damage can be done due to low applied voltage, damage of this type is usually excluded from the manufacturer's warranty. That's why they put it on there, plus or minus 10%. They're smart. They're not going to have to replace a bunch of stuff that's not their fault. Throughout this section, the term applied voltage has been used. This means the voltage at the motor terminals at the time the unit's attempting to start and run. Or if we were looking at a contactor, at the contactor. We were looking at a transformer, at the transformer. We don't mean at the disconnect, right? Applied voltage means right at the component we're testing. Electricity is like water, and the amount to start and run. Electricity is like water, the amount of the electrical volts. Pressure at the motor terminals will depend on the voltage pressure at the feed of the end of the circuit and the amount of current going through the conductors. Let's skip a paragraph that says, if low starting voltage is due to inadequate power transformer capacity, this problem must be referred to the electrical utility. This can be detected by the voltage drop measured at the transformer secondary terminals during the attempt to start. If the drop in voltage is due to inadequate wire size throughout the power distribution, the problem should be referred to a licensed electrician. And so the problem exists where if the breaker box has enough power, voltage, it's in our range, but they're using a wire that's smaller, in other words, it's not as good a conductor, and it has a sufficient length to drop the voltage, that's why we want you to take the voltage at the unit, what we're calling the applied, because it may be fine if they're coming into their house, but somebody, instead of running a number 6, they ran a 10 or something. And so when the thing's being used, that's another. We want to see it being used. It may register enough voltage when it's not being used. Kick that heater strip on, all 15 kW or whatever, and check it and see if it's dropped, okay? Here again, we're not licensed electrician, although some of you may be. But if you're a licensed HVAC contractor, you're not a licensed electrician. That's a separate license. We're not licensed to go beyond the disconnects. So if you're not a licensed electrician, you're going to have to refer that job to somebody else or do it on the side, but you're going to be breaking the rules of your license.
Does that mean we can replace the disconnect if it
Yes,
was bad?
we can. But we shouldn't be like running the wire to the disconnect or like that. And there are some if they're using a breaker in the breaker box as their disconnect, say they got an air handler with 10 kW sitting there in the room right where the breaker box is, and so instead of a disconnect they ran to a breaker, then we can technically get into that breaker. But that's not the case often now. Okay, relay armature sticking. All right, so for the most part here in this section, this is the moving parts. And you move a couple thousand times, sometimes you have a sticking armature. More likely though, that's not the problem. The armature is burnt or there's something in it like ants or something like that, okay? But we are aware that it's moving and it can wear down, so our armature can stick. I've been on plenty of calls where the contacts are they're welded shut together. They didn't shut cleanly. They chattered. We got enough amperage running through them, enough current that it just glazed them over and they stuck. So then it ran all the time. And then the inside unit would be satisfied. So the inside blower motor would cut off and it would keep running without a fan, so it would freeze up the coil. And same way with not as often with the blower motor, because we just remember, if we're using a blower motor relay, then we're saying it's less than 20 amps. There's less power there to burn up those contacts. Now let's look at 2615, shorted coil. Now this could be on a relay or a contactor. Excessive low or high voltage applied to a relay or contactor coil, the magnet, right, will cause excessive current draw the same as a motor. This excessive current draw will cause overheating of the coil, break down the insulation between the winding, and results in shorts between the wire turns and the coil. Shorts between the coil reduce the magnetic power of the coil as well as increase the current draw. But if I've got a winding supposed to go around 1,000 turns and it starts melting it off, instead of going around 1,000 times, it only ran around 500 times. Okay, less resistance, more power is going to flow through there, right? Now I got more power, I'm going to have more heat to melt more I'm over. Plus, my magnet isn't as strong. And with my magnet not being as strong, it's not going to pull it in as quickly and as hard as it should. And here's a good one here. It says, a noisy coil due to shorted turns will quickly develop into a burned out coil because the current drain and the heating are accumulative. And until the burnout occurs. Therefore, the coils that hum excessively should be checked and replaced before burnout coils. I have people asking me all that time, why is this contactor so loud? Well, maybe it's having some damage due to voltage or something, you know. 2616, a burnout coil.
Not me.
So, we all got fun. Burned out coils and relays or contacts are the results of adverse operating condition. It is probable that the burnout can be due to a defect in the coil itself, but this is remote. Now here's a test question. The principal reason for coil failure is improper voltage, right? Wow. Contacts and coils, you know, whether it be a blower motor or a contactor, is usually due to improper voltage. And we just said back on 2613, 2 sections ago, that low voltage was more common than high voltage. And so basically what they're telling us, there's a good chance you got a bad one, it had low voltage. When you're replacing it, that in itself is a reason to, once you replace it, I mean, great that you know what's wrong. Clay, I got 24 volts on this coil and it's not energized. I cut the power, I ohmed it out, and it's burned up. I'm going to replace it. That's excellent. But to be a better technician, you're going to cut it back on and you're going to check your voltage at it. Was it okay? You know, if it's not, don't leave it. Go back to your transformer. Take a look at that transformer. You know, maybe the transformer's not producing 24 because it didn't have the proper input, you know, whether it's 122, 4208, you know, or maybe it did. Maybe the transformer itself is just having trouble. All right, continuing on, I'm sorry. So here they go, they said, okay, so our 24 volts, same way, plus or minus 10%, we got 26.4 or a low of 21.6. And it says on units with 24 volt control systems, the major source of low voltage control is overloading of the low voltage transformer by the addition of damper motors, relays, solenoid valves, etc. All right, so let's just talk about that for a second. All right, so a transformer steps down our power, hopefully to 24 volts, because that's what all our controls are rated to use, 24. And so we have a tight little area. What did they just say? 21 to 26, somewhere in there? All right, so they said the number one cause is we overloaded the transformer. Okay. You know, I find that a little hard to believe that an engineer sitting up there and a computer didn't figure out what we needed, but it's possible. I guess if you put some accessories on, like a humidifier, maybe electronic. Okay, so anyway, it's possible. So what we have is a transformer is rated in VAs, volt amperes. All right, don't get worried, it's really simple. Where we rate a transformer in VAs is on the secondary side. What side is that? That's their low voltage, right? And they say to figure out what your VA rating is, and most units come with a 40. But sometimes you get a bargain on a unit that has 20. And I wonder why this one's cheaper, you know, that kind of thing. So anyway, they would say, hey, this is 40 VA. And what that means is volts times amps on the secondary circuit, right? And so they're saying, what should my volts be anyway? 24 times something, I can get up to 40. So just doing a little algebra here, right? We can move this over here.
1.66.
Thank you. If I pull over that many amps, the transformer's going to start giving us trouble. That's its limit. Could have a 20, right? Right. We have less here, right? I can't do that in my head.
Less than 1.
20 something. 9, 0.83. So, now, y'all say, well, how much amps does this pull? This coil. How many amps? I don't know. That's why you got an amp meter. Okay? But the more stuff we have on there, it's going to eat it up, right? Total amps in a parallel circuit, right? All right, so everybody understand how to read this VA. And they're saying we're exceeding our numbers. And once we exceed our number, we won't maintain our voltage. Okay? So it's pretty simple. I mean, if you see a problem with a 40, if they got it, shoot, I'm going to Johnstown, I'm going to give me an 80. Now, you go, well, why didn't they do it? Because they're selling under rules from the government, and they want their piece of equipment to consume as little electricity as possible. In other words, it's efficient. I put a bigger transformer in there, it's going to consume more electricity. I mean, not a ton, but you got to get every penny, every ounce you can on those things to make them seem efficient. Okay? Let's see, what else we got? Condenser fan overloaded, 2617. Let's take a look at this. It says it in the second paragraph there, y'all. On a propeller type condensing unit, we usually call these axial fans. The addition of airflow resistance over and above that built in the unit will cause the fan motor to draw considerably more current. This is just the opposite of a centrifugal, what some people may call a squirrel cage. So let's think about this. If I block up an axial fan, a propeller fan, the current goes up and it overheats. If I block up just the opposite, a centrifugal fan, the amp draw goes down because it's not working. It's sitting there spinning, it's not moving a thing. It loves it. If I open up a door to work on something and leave it running, try to move all the air in the room down. Now it may overheat, okay? So we use axial fans where we can. We use centrifugals because we don't want duct fires, right? Insulation falls down, something like that. Amp draw goes up, gets hot, gets the motor on fire. We don't want that. We use centrifugal fan. Now, but by using axial fans outside, like on a condensing unit, what's going to happen when the unit gets dirty? It's going to lower the inflow. What's that going to do to my current? Okay, go up. If it gets up high enough, it's going to overload it. We have an overload, a current overload. I showed that to y'all the other day, didn't I? That little overload in there. We got an overload in there. If it gets too high, we'll cut it off. Y'all look at this. Right here on the coil, there's this little silver rectangular box. That's our overload. And it sits in amps. If this thing gets too hot, it's going to cut it off, and when it cools off, it'll close back down and let the power flow through it. And so that is a problem. I know I've talked with this before. Down in Montevallo, we used to have a pizza place. Pretty good pizza. These, man, they were sloppy. And they'd come in, we had 2 big 5-ton units sitting right by the back door. The delivery folks would come in, and they would just sling their leather, or maybe it's pleather, but their pizza insulator boxes right there on top of them. And they'd call me down there Friday night, Saturday night. the air conditioner's not working, because you got to come on down there and you walk up and you're going like, well, cover it up. You know, these units, and let's think about this. If this fan motor gets hot enough where it cuts off, then it's not moving any air over the coil. That's going to, and I know we hadn't talked about mechanical refrigeration, but that's going to put my head pressure sky high. And when the head pressure goes sky high, then the compressor motor overloads. All right, so we want to keep this in fact on a condenser fan overload. That can be the problem. Now, a PSC motor, which this is, a permanent split capacitor motor, so we always have a run capacitor going, wired into the start winding. Capacitor always going to the start winding. Now, I know a lot of y'all and a lot of students in general have trouble realizing that this PSC motor was chosen for a reason. It had enough torque to even work inside a refrigeration system. So you start up against pretty high torque. It wasn't too expensive to make. You know, I mean, it's more expensive than a shake motor. And it had the strength of the torque, and it had some durability. It had some shortcomings too. Energy efficiency. That's a lot more efficient. Okay. So all that goes into why you use something. But the PSC motor, permanent split capacitor, is nothing but a split phase motor. That means it has both a run and a start winding. The difference is, in most, like if you work on any refrigeration equipment that's not, big, say a Coke machine or, a two-door, cooler or freezer or something that size or smaller, they may not have a PSC motor. They're probably going to have a split phase motor. And what they do is, to get that thing running, they energize the start winding. That gives it enough start torque to get going. And then they don't use the start winding. Well, on a PSC motor, we have power going to it all the time, but it rarely draws power through it. When it starts, it pulls power through the start winding and the start capacitor. Once it comes up to speed, though, you can put your do it. When you're sitting out here looking at some of these condenser units, and you go, things running, condenser fans running, I'm gonna put my my amp clamp around the start wire from the condenser fan, and it won't hardly draw anything. That's how they're designed. They're still hooked up, but the run is carrying the torque. Now, if for some reason that thing becomes stressed under pressure and it needs more starting torque, it will begin to pull more power to the start winding. That's why a PSC motor is more efficient than a split phase, because that it helps it run sometimes when we get under stress. Okay. Now, because of that, we can have a capacitor go bad and damage my fan. Burn it up. Or it can go bad and make the fan motor not bad, but appear to be damaged. Or we can have a fan motor that's going bad that can damage the capacitor. And so whenever we change a PSC motor, we always change the capacitor. We may be out here in the field, and I say, hey, did the capacitor test? And you say, yeah, it's got 10 farads, it's good. But when it heats up, maybe it doesn't. And that's something we can't check. I'll be back in 2 hours, ma'am. I'm going to recheck this capacitor. That's not going to happen. You're just going to put a new capacitor on. See? And so whenever we put in a new motor, we're going to put in a new capacitor, because we don't know unless we specifically know what damaged that fan motor that we're replacing. Might have been that capacitor, although it tests okay when it's cold. A lot of people throw those old capacitors on their truck and sell them. I'm like, you're crazy. burning people's motors up. I mean, I don't know how much I think I bought a 35.5 Saturday. I woke up, my house was hot, so I ran up to Johnstown and got one. Like $11. I mean, how much money are you gonna make by selling a used one? You know? I mean, honestly, so, but you always, all we can do is the best we can do. Technology on our testing equipment gets better. Test the capacitor, test the condenser fan motor, and this is mainly with an ohm and a capacitor tester. But if it doesn't have the proper voltage, we know it's not going to work right?
Fair question.
Yes, sir.
I changed my neighbor's condenser fan because her bearing locked up on her.
Okay.
Is her
A
capacitor,
mechanical problem, okay.
is her capacitor all right, or should I change it?
Might want to go back and change it. We don't know, and he could have owned that thing out and might have owned fine and had the right voltage. But, that's a different thing. Is it locked up mechanically, when steel and bearings give out? Personally, I would. If I'm going to go to the trouble of putting a new motor on it, I might absolutely going to change out the capacitor. Now, sometimes, y'all, people don't mean to hurt you, but they'll give you advice that's just not right. Okay? On a permanent split capacitor motor, all right, capacitor does not change the direction of the fan rotation. I heard, oh yeah, if it's got a dot on it, no. Okay. The direction of any motor with a start winding depends on how the flow of electricity goes through the start winding. In other words, it enters one side and exits another. If you rewire it, you cut this one loose, hook it to here, hook this one to here, it'll reverse. And they sell them like that. They'll have 4 wires coming out with 2 males and 2 females. And a lot of times they color code them. They go yellow and yellow, or purple and purple, or something like that. And it'll say on there, for counterclockwise, go yellow, yellow, purple, purple, or whatever color. And they'll say, okay, for the opposite direction, you just crisscross it. And they'll say yellow, purple, yellow, purple. And all they're doing is how they're feeding the electricity through the start winding. That unless that motor was done like that, we can't do that. Unless you're going to rip a motor apart, go in there and put you a stake on to change it. About the only other thing you can do is to take the ends off, pull the rotor out, and put it back in backwards if it would fit. Okay? The capacitor doesn't have anything to do with deciding the direction. Now, what a capacitor will do for our fan motors, our run capacitors, I should say, is when it starts off, it helps give it extra torque. Well, this capacitor can break down 2 ways. All these capacitors are fused. That fuse can blow and you won't get any reading out of it. Or its capacitance cannot be enough. Does that make sense? All right. With a capacitor that has blown fuse, there's no power going to your start winding. You tell me the situation. Is it with the propeller on top of it, or maybe it's hanging down, the propeller's on the bottom of it? I don't know. But without the start winding, much less the capacitor, no power to the start winding, it may or may not have enough power to start spinning. I see many people spin it, and it gets to running. That's a good sign that the capacitor's bad, right? Because it didn't have, guess what? If it spins in the opposite direction, does the run winding care? What determines the direction? The start winding. So if you spin it in the wrong direction because the wind was blowing that, it's going to run in the wrong direction, y'all. Okay? Yes, sir.
The fuse you're talking about the little bit of fuse on top of the phone?
It's internal, you can't see it.
Oh,
What you're talking about is on a start capacitor, y'all.
Okay.
They usually put like a 20,000 or a 40,000 ohm resistor. And that way, when that thing starts up, that circuit is taken out, y'all. because you can't keep that thing in the circuit or it'll blow. But when they cut it off, it had power on it, and it still has charge in it. And so they dissipate that electrical charge with that resistor. It uses that little electricity. It uses it up. And I think I told most of y'all, when you're out here doing capacitor tests, most of the new meters will read across a bleed resistor fine. Clayton's got 200. But some of the, like Fluke makes a really good meter, but if you get a Fluke that's 5 years old or so, a lot of them won't read across a bleed resistor. It's just, and I used to have one like that where I'd have to get my dikes and cut out the bleed resistor, then test across it. If it was good, then I had to get me a little wire and connect it back because I didn't have a soldering iron on the truck. Okay. Condenser fan, bad, 2618. Did somebody else have a question? It said these can be caused by high voltage, low voltage, overload, improper lubrication. Okay, I know I have beaten improper voltage, so I'm not going to go with this. I know I've beaten y'all to death with that. Lubrication. We got some information here you're not going to find anywhere else. Okay, that's a reason never to lose this. If you'll be looking, you call me up in 10 years and you go, Clay, I'm looking for some information on lubrication. Electric motors that require periodic lubrication. This is not to be confused when you pick one up and it says permanently lubricated. That means whatever you do, do not lubricate. Should be checked and oiled with care and common sense. Short of supply. Because 1/2 teaspoon of oil once a year is sufficient for lubrication for most standard motors, does not mean that more than 1/2 teaspoon of oil once a year or more is better. More motors are damaged from over-oiling than any other reason. When a motor is over-oiled, the oil only runs out into the bearing, into the inside of the housing, and sprayed off on the rotor, throughout the interior of the motor, the coastal windings, the terminals, the start switch, causing gumming of moving parts, carboning of the points, contact, and motor failure. It is better that a motor be oiled every 2 years than more often. Okay? Type of oil. Very important. Oil should be heavy enough to provide proper lubrication, but must not contain soaps, detergents, or any other additive. 3-in-1, WD-40, phenol, or any other rust prevention oil should never, ever, 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 ever be used. Also, ordinary motor oil should never be used, regardless of the make and grade. Use electric motor oil or refined mineral oil of a weight and grade specified, which is generally number 10. Okay? So, this is a condenser fan motor. I can say that pretty positively because it's one speed. I got a common start and run, right? One speed. So, good chance this was meant to be outside. Alright, this thing may be mounted up or down, right? I don't know, depends on the brand. But when you buy this replacement, if this motor is not closed, say it's shut down, then they will sell you, or you need to make sure they sell you, a rain guard for it. Or if it's going to be shaft up and it's not rainproof, they're going to have to sell you a rain guard. Okay, we don't want rain running through them. All right. The next thing is, whatever side is down, they're going to provide you with this new motor, and there's going to be some plugs on it, little plastic plugs. That's not for oiling. If you read on one that says oil here, okay, that's an oil. But what those are is to drain out condensation. this thing is not airtight. In the winter, it's going to get cold. It's going to get cold, y'all. It's metal. Air is going to get in it, which has moisture. As that temperature drops, it's going to condense on the metal in there. When it does, we want it to drain out. We don't, we're going to start an electrical component with a ton of water in it. And we're going to have either a fire or electrocution or something, okay? All right, so everybody clear on oiling and on drainage, okay?
Those plastic plugs that you're talking about, whenever you first install, do we have to unplug it?
You have to do it because they don't know if it's going to be up or down. It's your job to pull it out on it if you're doing a motor replacement. All right, I'm going to stop the lecture right there. It says start relay bad. We're going to talk about potential relays.